In this video, we're going to see how to do a hypothesis test for two population proportions or two population means. For the proportions, we're going to be looking at a problem from section 11.1. And so not representing any real data, just we have some sample data. I don't really know what it represents, but just to show you, if you know your mean, or sorry, if you know the number of successes, the number of trials for both of your populations, and then what it is you want to test. So here I am comparing two proportions. So I'm going to come over here to my plus sign and select inference. And then I am doing a z-test for proportions. And notice that here is where I enter sample one successes and sample size. So sample one data successes is 109 and sample size is 475. To enter that data for sample two, I just hit the plus sign here, and now it gives me the entry boxes for that. And for sample two, we have 78 successes and a sample size of 325. So we've entered our statistics. Now we're just going to hit create test. And we are interested in testing whether the proportion in P1 is greater than the proportion is P2. So we're going to select significance test. And then notice here we're comparing P1 minus P2 to 0 is going to be my null hypothesis. So if I am comparing P1, if I'm testing P1 less than P2, that would mean that P1 minus P2 would be less than 0 or to the left. So this is going to be a left-tailed test here. If I'm testing P1 is greater than P2, then that would be P1 minus P2 would be greater than 0. So I would do the right-tailed test. And then, of course, both would give me the two-tailed test. And we can see from our result that we have a p-value of 0.365. And so if we were having the significance level alpha of 0.05, p is not less than alpha, so we would not reject the null hypothesis for this one. When we are comparing two means, we have a couple different ways of doing it, depending on whether the samples are dependent or not. And by dependent samples, we mean, for example, looking at a before and after situation. A group of people are given a treatment, and we test something before their treatment and after their treatment, and we're comparing each of the individual results. So for each person in the study, I'm comparing what's the difference between their results before their treatment and after their treatment, which is different than looking at a group of people, taking the mean of their results, another group of people, and taking the mean of their results. So the first case we'll look at is the dependent samples. And I've already entered this data. The first thing that you're going to do is you're going to enter the before data in your first column and the after data in your second column. Let me show you how I got this table. I got that by clicking the plus sign to add an item and then selecting table. And then I just entered the XI data in the first column. So just type in a value, hit enter, or hit the down arrow, and then click on this cell and you can start entering the Y values. So once you have all of your X values and your Y values, what you're interested in is the difference between these. So for the first person in my study, their difference is going to be 19.4 minus 19.8. And the way that I do that is I just come over here and I tell it to calculate X1. Oops, I click in here, X1 minus Y1. So that gives me all of those paired differences. You can see in the first column, I have 19.4 minus 19.8, which is negative 0.4. And then what I want is I need to know the mean of those paired differences and the standard deviation of those paired differences. So I can just use mean. And again, I can type X1 minus Y1. That calculates the average of all of these for me. And then standard deviation, X1 minus Y1. And that's 3.83. Once I have the mean and the standard deviation, I am ready to compute the confidence interval and hypothesis test. And I'm just going to come over here, add an item, and I'm going to add that inference item. And this then would be just a t-test, because now I just have a mean and a standard deviation. And I'm going to do a test on the mean. I'm not using the data because I've calculated the mean and standard deviation. So I'm going to click on stats here. And then my sample size is just the number of pairs that I had. 1, 2, 3, 4, 5, 6, 7, 8 is my sample size. The mean is what I calculated here, the mean of those paired differences, negative 1.075. And then the standard deviation of the paired differences, 3.833. Now I can create my test, and I want a hypothesis test, so I'm going to click there. And then I see what was my hypothesis. Oh, we didn't have one there. Oh, yes. Test if the mean of the paired differences is not equal to 0. So that would just be a two-tailed test, right? The null is that the mean of paired differences is 0. The research hypothesis is that it's not 0. So I'm checking both sides. If I had the paired differences was less than 0, that'd be a left test. Paired differences is greater than 0 would be a right test, but not 0 is a two-tailed test. So you can see that my p-value is 0.454, which is not less than alpha of 0.01. So I would not reject the null hypothesis for this set of data. We can also see the confidence interval if we wanted to. I think it asked us for a 99% confidence interval here, so we just change that to 0.99, and you can see that the confidence interval goes from negative 5.817 to 3.667, which again does not indicate that there's any difference in the before and after for this one. When we have independent samples, so we have maybe two groups and we're comparing treatments, and we want to compare the means for each of those samples, then we're just going to, we'll go back here to this one. We're just going to come over here and we're going to select our t-test. And for this one, I'm again selecting statistics because I have the sample size, sample mean, and standard deviation. And I'm going to enter the information for two samples. So I can click here, and now I'm able to enter sample 1 statistics and sample 2 statistics. For sample 1, my sample size is 40. My mean is 94.2, and standard deviation is 15.9. For sample 2, I had a sample size of 32, a mean of 115.2, and a standard deviation of 23. And now I want to test whether the mean from the first population is less than the mean from the second population. So I'm going to click on significance test. And again, mu1 less than mu2 would be the same as mu1 minus mu2 being less than 0. So again, this is a left test. And I am testing at the significance level of 0.05. My p-value is 0.0001, which is much less than that. So that tells me that I would reject the null hypothesis. If I'm interested in that 95% confidence interval, I'm just going to click on confidence interval here. And then I'm going to select, oh, it's already at 0.95. So my confidence interval, the lower bound is negative 30.59, and the upper bound is negative 11.41. I hope this was helpful, but please reach out if you have questions. Reach out to either me or your own instructor. You can reach me at jane.keller@joyce.edu. Thanks for watching and have a great day.